Hello everyone, welcome back to our channel Learn Science with Saran. In today's class, we are going to see the topics such as types of lens and then ray diagrams, case studies. The last one is magnification of lens, power of the lens and lens formula. Okay. In today's class, we are going to discuss about these topics. Okay. We'll start with the first one, lens and then types. When we go for lens, the mirror is directly opposite to the lens. Okay. Now please listen here. In board examination, you will get one question from mirror as well as one question from the lens. Okay. Now please listen to the video. Convex lens. This diagram represents the convex lens as well as this diagram represents the concave lens. Here, a lens. What is the lens? Lens is nothing but it is the combination of two mirrors. For example, please see here. In this diagram, you can able to see a convex lens. This lens is made up of one concave, one convex lens combined together to form a convex lens. Okay. Before that, we should know one key point. Today's key point is a concave mirror is also known as converging mirror, as well as a convex lens is known as converging lens. Then a convex mirror is known as diverging mirror. Here a concave lens is known as diverging lens. The mirror is directly opposite to the lens. Now we are going to see the next topic. The next topic is here you can able to see the distance between the M and N is known as aperture of a lens. Okay. Here the center point is known as optical axis of the lens. Here this F represents the focus and then this C1 or 2F1 represents the center of curvature of a lens. Here, this lens is completely made up of two mirrors combined together. So, here one F1 is called as focus, F2 is also called as focus, as well as 2F1 is called as center of curvature, 2F2 is called as center of curvature. This line is represented as principal axis of the lens. Okay. Here, the distance between the M and N is known as the aperture of lens. The same is applicable for the concave lens. Okay. The same thing is given in the sentence. Okay. Please go through. Please pause the video. If you want to take the notes, you can take the notes by using this video. Okay. The next one. The next one is we are going to the rules of the ray diagram. There are 4 rules or 3 rules of the ray diagrams. Okay. We should know about these rules to apply it in the case studies. Okay. Here we are not going to get any ray diagrams in the question paper. We are going to get all the case studies. They are going to give some case study. In the case study, we want to know which lens is used and what type of image is formed. Like that, this type of question can be expected in your board examination. Okay. Here, as the same as the mirror. Okay. This lens is called as convex lens. This lens is called as concave lens. Here, this line is called as the principal axis. The center point is known as optic center of a lens. This point is known as F2. This point is known as F2. This is F1. This is F2. F1 and F2 are the focus of the lens. Okay. Please listen here. We already know this topic called refraction of the light. Here, refraction of light takes place because this type of medium is known as rarer medium. And this lens is completely made up of glass. So we can directly say that this is a denser medium. When a ray of light passes through the rarer to denser medium, what will happen? Refraction, bending of light takes place. Okay. So all the topics are interconnected with each other. Okay. Now listen here. When a ray of light parallel to the optic axis or parallel axis of the lens, what will happen? It directly passes through the focus. It directly passes through the focus. The same will be applicable for the concave lens. This lens is called as converging lens. This lens is called as diverging lens. Okay. Now we are moving to the second rule. Here we can able to see the direct opposite to the first ray diagram. Okay. Please listen here. This lens is known as convex lens. When a ray of light passes through the focus and then refraction takes place because we are using a glass medium here, and then what will happen? It comes back as a parallel line. Okay. The direct opposite or reciprocal of the first ray diagram is the second rule. Okay. Now we are moving to the third rule. What is the third rule? The third rule is nothing but here refraction of light does not take place because we are talking about the optic center or optic axis of the lens. Okay. Now when a ray of light passes through the optic axis or optic center of the lens, what will happen? It will directly pass through the lens. There will be no refraction. There will be no reflection takes place. It is applicable for both concave and convex lens. Okay. When we are talking about mirror, when a ray of light passes through the center of curvature, it gets reflected and comes back through the same path. It is happening in the mirror. But here we are talking about the lens. In lens, when a ray of light passes through the optic center or optic axis of the lens, nothing will happen. It will directly pass through. That's all. Okay. Now we are moving to the case studies. Here, please listen here. These are the most important topics. First one, we already know something. A concave mirror and convex lens are also known as converging mirror and converging lens. The point is applied here. We already know the rule diagram, the ray diagrams, right? Here we are going to apply the ray diagrams here. What ray diagram is applied here? Whether first rule, second rule, or third rule. We can directly say that the first rule is applied here because when a ray of light parallel to the principal axis, it passes through the focus. So, the object is kept at the infinity. Here, the position of the image will take place at focus because it follows the first ray diagram or first rule. Okay. So, what is the nature of the image here? It will be real and inverted. Where we get real and inverted image? In concave mirror, we will get real and inverted image. As well as in convex lens, we will get real and inverted image. Okay. Now, we are moving to the next case study. The next case study is simple. Here, we can able to identify the ray diagrams applied here. What are the rules applied here? Yes, you're correct. We can directly say that the first and the third rule are applied here. What is the first rule? When a ray of light passes parallel to the principal axis, it comes back or it passes through the focus. The third rule is when a ray of light passes through the optic center or optic axis of the lens, what will happen? It will directly pass through. It never comes back. There will be no refraction takes place. Okay. Here, the position of the image is beyond 2f1. What is 2f1? The center of curvature is known as 2f1 here. Okay. Beyond means I'm just going to keep it backside of the center of curvature. After that, the position of the image, where the image moves, when the incident light and the refracted light meets each other to form an image. So the image is formed between focus and center of curvature. F2 and 2F2. Here F2 is the focus and 2F2 is the center of curvature of the lens. Okay. So what is the nature of the image? It will be real and inverted. Okay. Now we are moving to the last case study of convex lens. Here, please listen carefully. This is the most important topics in your board examination. Okay. Here, the position of the images between F1 and 2F1 opposite to the second case study. Okay. So when the position of the object is kept at focus and center of curvature, where it will be formed? It will be formed beyond the 2f2. What is beyond 2f2? 2f2 is called as the center of curvature of a lens. Okay. Here the image form will be enlarged because we are using a convex lens. What is the nature of the image form? It will be real and inverted image will be formed. Okay. Now we are moving to the next case study for concave lens. What type of lens is concave lens? A convex mirror and the concave lens are commonly known as diverging mirror or diverging lens. When a ray of light passes parallelly to the principal axis, what will happen? The divergence will take place or refraction of light will take place. Okay. Here in this ray diagram or in this case study, we can able to see that clearly when object is placed at infinity. So I'm going to place the object far away from the lens. So where I'm going to get the image? The image will be formed at the focus because we already know something. What's the first rule? When a ray of light passes parallel to the principal axis, what will happen? It will passes through the focus. So the image will be formed at the focus. That's all. Like the nature of the image form, it will be virtual and erect. The same as the mirror. What is the nature of the image formed by a convex mirror? It is virtual and erect, as well as concave lens also virtual and erect. Now, the second case study. What are the rules applied here? Yes, you are correct. We have applied first rule and the third rule. Same as the first rule and third rule. What first rule? When a ray of light passes parallel to the principal axis, it passes through the focus. Okay. Here, divergence takes place, refraction takes place. Okay. Then, what is the third rule? When a ray of light passes through the optic center or optic axis of the lens, what will happen? It directly passes through the lens. Okay. So, I'm going to keep the object. Position of the object will be infinity on optic center. The position of the object will be infinity. So, we can directly say that the between position of the image will be between focus and optic center. Same place. If I'm going to keep somewhere means, again the image will be formed there itself. Okay. So, what is the nature of the image here? The nature of the image formed is virtual and erect. Okay. Now we have completed the case study. Now we are moving to the next topic called as uses of convex lens. Where we are using convex lens? All the places. Where we are using convex lens? All the places. Where? First one, projector. We are using the convex lens in the projector. What's happening in projector? In that projector, there is a small display in the projector. It magnifies all the things which enlarge the image. So we are going to get the enlarged image on the display board. Okay. So overhead projector, focus sunlight, and the simple telescope, projector microscopes. The microscope is the best example for convex lens, and then magnifying glass. Magnifying glass are the great example for convex lens. Okay. So be careful while writing the exam. A concave mirror is directly opposite to the convex, or concave mirror is directly opposite to the what? Concave lens. Okay. So mirror is directly opposite to the lens. Please listen to the next topic. The next topic is uses of concave lens. Now we are using convex lens, concave lens. We are using the concave lenses, spy hole doors in the door, and then we are using it in the glasses. The glass spectacles which we are using are made up of concave lens, and then some telescopes, binoculars are made up of concave lens. Okay, I think everyone can able to understand. The next topic is mirror formula, as well as here we are going to study about lens formula. What's lens formula? What's mirror formula first? Mirror formula is nothing. 1 by f is equal to 1 by v plus 1 by u. Instead of plus, we are going to use minus. Why we are using minus? What is the focal length of a concave mirror? Focal length of a concave mirror is negative. Focal length of a convex mirror is positive. So plus into minus, minus, because one convex lens is made up of a concave and convex mirror applied together to make a lens. So combining two mirrors will make a lens. So plus into minus, minus. So what is the lens formula here? Lens formula is equal to 1 by f is equal to 1 by v minus 1 by u. What is v here? The v is the image distance. What is u? U is the object distance. What is f? F is the focal length of the lens. Okay. Now, the next topic is called as magnification of a lens. What is the magnification of a lens? Magnification. Magnification means enlarging of the lens. Okay. For example, if we got our favorite person mobile number, we are going to zoom the DP of them to look whether what dress they are wearing, what watch they are wearing. Okay, like that. Enlarging of the image is known as magnification. Okay, here m is equal to height of the image divided by height of the object. So we can write it as v by u or h dash by h or hi by ho. Okay, in mirror formula, magnification m is equal to minus v by u. Here it is v by u. I already told that the mirror is directly opposite to the. Lens. Okay. Here, the last topic and the interesting topic is power of a lens. What is the power of a lens? For example, some of us are wearing spectacles because of their eye power. Okay. How to measure the eye power? The reciprocal of the focal length is known as power of a lens. The reciprocal of the focal length is known as power of a lens. So, power is equal to 1 by focal length. P is equal to 1 by f. Here, P is equal to 1 by f. So, we will get one more question or a MCQ in our board exam. What is the MCQ here? SI unit of power. What is the SI unit of power? It is diopter or capital D. What is the spelling of diopter? D-I-O-P-T-E-R? No, it is not D-I-O-P-T-E-R. It is D-I-O-P-T-R-E. The spelling of diopter is D-I-O-P-T-R-E. Please don't forget this. Next, what is one diopter? One diopter is equal to 1 meter power minus 1. Okay, we have completed all the topics of light chapter. Now, what are the topics covered today? We have covered what are the types of lens and the ray diagrams, case studies, uses of concave and convex lens, and then we have covered lens formula, magnification of lens, and the last one is power of a lens. Don't forget to click the bell button, subscribe my channel, share with your friends. Tata, bye bye. We'll see you in the next video. Keep going, keep going.